A summer camp counselor wants to find the length x in feet across the lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800, 1,400, 700, 800, respectively. The segments AC and DE intersect at B, and angle AEB and angle CDB have the same measure. So there's a little bit of information here to unpack, but the key thing that I think you ought to pay close attention to is the keyword respectively. And what that means is, in whichever order things were mentioned here, like AB, EB, BD, and CD in that order, the numbers also are in that same exact order. So that means AB goes with 1800, EB goes with 1400, so on and so forth. In fact, let's go ahead and write those numbers in. AB is 1800, EB is 1400, BD is 700, and CD is, of course, 800. Now, these two triangles are similar, and we can prove this because otherwise we cannot set up a proportion to solve for the missing piece. But to prove that these triangles are similar, we were given a fact. One of the facts given was that this angle here is congruent to this angle here. Angle D and angle E are congruent. But we also know from our knowledge that this angle here would have to be congruent to that one because those are vertical angles. And recall, when two angles in two triangles are congruent, that's enough to prove similarity. But just to completely prove this, angle A would have to be equal to angle C. Now with that knowledge, we can set up our proportion. It doesn't matter how you set it up, just be consistent. So in our case, let's just set the small triangles measurements up top, and we'll set the bigger triangles measurements on the bottom. So since the question is asking us to solve for x, we have to feature that. So starting with the small one, BDC, side DC corresponds to AE, which is the x that we want. And then we can set that equal to side BD for the small triangle corresponds to side EB. Once we've set this up, the rest is just plugging in numbers. So DC is 800 over AE, which is x, over BD, which is 700, over EB, which is 1,400. Notice real quickly that we can actually reduce these. The 700 goes in here once, and 700 goes into 1,400 twice. So really this is 800 over x equals to 1/2, and to solve for these we cross multiply. So x ends up being 1,600. So the distance around, or across the lake rather, is 1,600 feet. That's your answer.